So now we discuss some of the questions from transition elements and also for complex compounds or coordination compounds from Comet K, which are appeared in the previous entrance exams, which are very important. One thing you have to remember from these particular questions, every time from transition elements and complex compound, every time 3 questions are appearing. So you concentrate more on these particular 2 topics, transition elements and complex compounds. We will discuss what are the questions appeared in the previous entrance exams in this particular Comet K. Now question number 1. IUPAC name of the complex is. What is the complex is given? C, Cr, Cl2 NH2 taken 4 times. Cl2 NH3 taken 4 times. NO3. This is the complex given. Let us name this actually according to our IUPAC naming, tetramine dichloro chromium 3 nitrate. Let us check the options. Answer is what? Tetramine dichloro is said. Tetramine dichloro chromium 1. No. Actually oxidation number coming to be 3. Coming to option B, dichlorotetramine. Amine has to come first, later on only chloro. Therefore it said dichloro, that is also not correct. Coming to C, tetramine dichloro chromium 4 nitrate is said. Actually oxidation number 2 negative, 1 negative. Total coming to be oxidation number 3 only. Then option D you come. Tetramine dichloro, yes, tetramine dichloro chromate, chromium. Tetramine dichloro chromium 3 nitrate, chromium 3 nitrate. This is the correct answer. So for question number 1, answer is D. Coming to question number 2. Question number 2. Coordinate number of nickel in nickel trace oxalato complex is given. Trace oxalato. Yes, you know, oxalato ligand is what bidentate, 3 times it is there. Then total number of chemical bonds around the nickel is actually 6. Coming to option A, it is what? 3, and B is given as 12, and C is given as 6, and D is given as 4. In this particular complex, what is given the complex? Nickel C2O4 taken thrice, O4 taken thrice, and this is what is given is minus 4. Yes, it is plus 2 complex, we agree, and 3 oxalato ligands, each is bidentate, therefore coordination number coming to be 6 only. So for the question number 2, question number 2, the answer is C. Coming to question number 3, which of the following metal ions is colored? See, once a question on colored, clearly observe the options given. Which metal ion is carrying unpaired electrons? Coming to option A, titanium plus 4. You know, titanium plus 4 is what? D0, no unpaired electron. Coming to B, vanadium plus 4. Vanadium plus 4. Vanadium atomic number, vanadium, that is equal to 23. It is what? D3S2. What is given? Vanadium plus 4 is given, right? Vanadium plus 4. 4 electrons lost. How many unpaired electrons remaining? 1. But I said, wherever a metal ion is carrying unpaired electrons, yes, that will be exhibiting color. So coming to copper plus 1. Copper plus 1 is D10. Coming to D option, Zn plus 2 is D10. Option A and C and D, they are not carrying any unpaired electron. Only in the option B, vanadium plus 4 carrying D1 configuration, 1 unpaired electron, therefore that definitely exhibit color. So here answer is B. Question number 4. Question number 4. An example for the complex anion is seen. The bracket part should be what? Anionic. Coming to option A, hexamine platinum ion. Hexamine platinum ion. C, cupramonium ion. And C, ferrocyanide ion. And hexammonium chromium ion is in. Hexamine chromium ion is in. Now, option C, if you consider ferrocyanide ion is said. Ferrocyanide. Generally, we write ferrocyanide like this. Ferrocyanide ion. This is carrying what? Negative charge. Therefore, The question number 4, answer is what? C. Ferrocyanide, Fe plus 2, then it is what? Answer C. Coming to question number 5. The hybridization of nickel in nickel tetracarbonyl is nickel tetracarbonyl. Yes, simply written, that is right, nickel tetracarbonyl. We are thoroughly discussing about this particular complex in our discussion about in the complex compound tetracarbonyl. What actually nickel is what? 28. 28 means what? D8S2. Since in this particular nickel is with a 0 oxidation number, nickel is 0. Since it is strong field, electrons are pushed to d orbitals. In this particular complex, D is becoming D10. Definitely it is sp3 and tetrahedral. So let us see the options now. The nickel tetracarbonyl, this is the complex, then sp3 and tetrahedral. So hybridization of nickel in the nickel tetracarbonyl complex is definitely it is sp3. So answer is A. See question number 6. CO ligand is, what is the name of this particular CO ligand? What we call this is, A is given as what? Carbonyl. B, carbonium is not positive, therefore you cannot say it is carbonium. And C is what? Carboso. No, it is only carbonyl. So next, carbonosium. No, that is also not correct. Simply CO ligand is called as carbonyl. So answer is A. Question number 7. IUPAC name of the complex K3FeCN taken 6. See, this repeatedly appears in the examinations. This is, you see, this is already covered once. IUPAC name is saying what generally we call potassium hexacyano, oxidation number of iron is what? +3. Potassium hexacyanoferrate 3. Check the answers. Potassium ferricyanide, no. And potassium ferrocyanide, potassium hexacyanoferrate 3. This is the correct answer. Answer is C. Next, coming to question number 8. Question number 8. Complex forming tendency of central ion increases with a tendency of formation of complex for a metal ion depend on what factor? The size is small, charge is more, that will be having greater tendency. Let us check the options now. Increase in size of the cation, no. When size is increasing, tendency will decrease, but we want the increase in the tendency to form a complex. So decrease in size of the cation. Once cation size is decreasing, charge density will be increasing. Then that particular metal ion is highly capable of forming the complex. So here option B, B the answer. Question number 8, answer is B. Coming to question number 9. Question number 9. The solution of the complex in water. Solution of the complex Cu NH taken 4 times sulfate in water with, give the test for Cu +2 ion. A is what? +2 ion. No. Once it is there in the bracket, it won't give any test for copper +2. Next. The test of ammonium. No. Amine ligand is also within the bracket, so it won't give any test of ammonium ion. Give the test for sulfate ion. Definitely this particular ionages. What is the complex given? Check it. Cu NH3 taken 4 times sulfate. This you are putting into water. Then Cu NH3 taken 4 times +2 plus sulfate ion. This sulfate ion can be easily identified here, not copper +2 or not amine. So sulfate ion can be identified. So answer C, give the test for sulfate ion. This is the answer. Answer C. Next question, question number 10. NO plus ligand is nitrosonium. A is nitrosonium, B is nitrosyl, A is nitronium is said. No, nitronium is NO2 plus. B is what? Nitrosyl. C is what? Nitrosonium. Correct answer again he said nitro. So correct answer is what? C, nitrosonium. Any positive ligand is given or pronounced with the EM. Therefore nitrosonium. The correct answer for this answer is C. Next question number 11. The UPSC name of K4FeCN taken 6 is. Here one more complex, iron complex. K4FeCN taken 6. This is the complex. According to UPSC, how to name it? Potassium, hexacyano. What is the oxidation number of iron? +2. Therefore, potassium, hexacyano, ferrate 2. That is the correct answer. Ferrate 2. Let us see. A. Potassium ferricyanide. Ferri means +3. No. Coming to B. Potassium ferrocyanide. Potassium ferrocyanide. That is also not IUPAC. According to IUPAC, it is not correct. Coming to C. Potassium hexacyano ferrate 2. That is the correct answer. So here answer is C. Next question number 12. Question number 12. The number of unpaired electrons in ferric ion Fe +3. Very simple to see. Ferric ion, iron, 26. 26 means we can make it D6S2. But what is the ion is given? Ferric ion, Fe +3. 3 electrons lost. What is remaining? 5, D5. How many unpaired electrons? 5 unpaired electrons. So let us check the answers. A is given as 2, B 3, C is 4, D is 5. So 5 unpaired electrons. So answer D, the correct answer for this, answer D. 5 unpaired electrons. Coming to question number 13. In 3D series, we move from scandium to zinc, paramagnetism. 3D series, scandium to zinc. How the number of unpaired electrons changing, let us see. Now, talk about 3D series is saying, let us talk about scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Then the electronic configuration of scandium is what? D1, D2, D3, D5 exception. No. Next it is also D5, it is again D6, it is D7, it is D8, it is D10, it is also D10. See, number of electrons 1, 2, 3, 5, 5. So here to here it is actually increasing. Here to here increasing. Again number of unpaired electrons are decreasing. So let us check the options. Increase is said. 3D it's scandium to zinc increasing is said, not gradually increasing. Now coming to NEET, B is given as a decreasing. No, actually increasing and decreasing. Let us check the answer. See, first increases to a maximum and then decreases. D option, first decreases is said. No, it is not decreasing, increasing. First increases, again decreases. So for this particular question number 13, answer is C. Coming to question number 14. Question number 14. The number of ions formed by sodium argentocyanide is sodium argentocyanide. First let us write the formula of the complex. Sodium argentocyanide. This is the complex. Once you are putting into aqueous solvent like water, check it what you get here. Na plus you are getting, and a complex ion you are getting AgCN taken twice. This is the complex ion you are getting. This is what it is. Let's check the answers. The number of ions is saying, number of ions, actually 2 you are looking on the board. Let's check the answers. A is what? 2, B is 4. There is no choice for 4. And C 3, no. And D 6, there is no choice for getting of any more than 2. 1 plus 1, only 2 ions. So here only 2. Therefore answer is what? A. Coming to question number 15. Question number 15. So NO is called nitrosyl, nitronium, nitrosonium. Simply NO is given as what? Neutral ligand. they will simply say nitrosyl. So NO is generally called as what? Nitrosyl. Therefore, answer is what? A. Coming to question number 16. 16. Nickel carbonyl has. Nickel carbonyl has. So many times this question is appearing. Nickel tetrachloride, nickel tetracyanide, nickel tetracarbonyl. These three are very, very important. Now, nickel tetracarbonyl. Tetracarbonyl. Yes, nickel is what? 0 oxidation number in this. Nickel 0 oxidation number 28. You know, D8S2. 0 means S electrons are, this is strong field. S electrons are entering into D. D becomes what? D10. So d orbital is fully filled. Therefore, it has to involve compulsory sp3 hybridization. Geometry should be tetrahedral. So nickel carbonyl has, what are the options? Check it. Linear structure. No, not linear structure. And tetrahedral structure. C is scale-planar structure. D is octahedral structure. There is no choice for any octahedral and scale-planar. It is sp3 and tetrahedral. Therefore, answer is B. Question number 17. Cuprous ion is cuprous ion, cupric. Cuprous means Cu plus, no, and cupric means Cu plus 2. He is only talking about cuprous ion. Cuprous ion means this one. What is the actual electronic configuration of copper? D10S1. Cuprous means what it will become? D10. Let us check the answers now. A is diamagnetic and B is paramagnetic. C is ferromagnetic, D is non-magnetic. This is definitely what? Copper plus 1, D10, no unpaired electron, it is simply diamagnetic. So answer is what? A. Diamagnetic. Coming to question number 18. Question number 18. D2sp3 hybridization of atomic orbitals gives D2sp3. D2sp3. Scale-planar structure. You see, scale-planar means there should be dsp2 hybridization. But he is saying D2sp3. Coming to be octahedral structure. See, tetragonal structure. D is what? Triangular structure. Triangular structure. Only octahedral geometry, D2sp3. See, total number of orbitals involved. 2 d orbitals, 1 s orbital, 3 p orbital. Total orbitals involving are what? 6. 6 bonds, 6 coordination number. Definitely it should be what? Octahedral. So 18 answer is B. Question number 19. Question number 19. An example for negative ligand is here. Many different types of ligands are there. Neutral, positive, negative. Let us see what is the negative ligand. Nitro. Nitro means NO2 minus. No, nitro. NO2 minus. Second one is carbonyl, you know, CO, carbonyl. Second one, nitronium. Nitronium means NO2 plus. Nitronium means NO2 plus. And nitrosyl, nitrosyl means simply NO. So what is said is an example for negative ligand. See, this is only the negative ligand. So here answer is A. Question number 20. Question number 20. The number of ions produced by the complex CONS3 taken 4 times. CO NS3 taken 4 times. Taken 4 times. Cl to Cl. Cl to Cl. This is the complex. Number of ions produced. Only 2 ions. See, this 1 ion, this 1 ion. 1 anion, 1 cation. Only 2 ions. Let us check the options. A 3 ions. No. B 2 ions. C 4 ions, D 7 ions. Only 2 ions, 1 plus 1, only 2 ions. This is the anion, this is the cation, only 2 ions. Answer is what here? What is given? 2, 2 is what? B. So answer B. Coming to question number 21. 21. The metal which will not give hydrogen with dilute hydrochloric acid is. The metal which will not give hydrogen with dilute hydrochloric acid. See, generally According to electrochemical series, recollect electrochemical series, hydrogen. Hydrogen electropotential value is what? Reduction potential value is 0. Which are having above hydrogen, this is what having what? Negative reduction potential. Which are below, these are having what? Positive reduction potential. Given options is the tin, B is what? Manganese, C is what? Copper, D is what? Aluminium. See, tin, magnesium and aluminium, they are having negative reduction potentials. Only copper is having positive reduction potential. Only copper is having positive reduction potential, more reduction potential. Therefore, copper cannot give easily hydrogen gas with the dilute hydrochloric acid. So, answer is C. Question number 22. Which one of the following ions has an octahedral structure? Among the given, let us see octahedral structure. Octahedral structure means there should be coordinate number 6. Option you take AgCN taken twice, and option B CuNH taken 4 times. 4 coordination number. 4 coordination numbers may be scale pen or tetrahedral. Option C you take HgI4, and again coordinate number is again 4. And option D you come FeCN taken 6. C. Coordinate number 6, definitely it is octahedral geometry. So far, question number 22, answer is D. Answer is D. Question number 23. Question number 23. Stainless steel is an alloy of. See, there are different types of alloys, but you have to remember some of the important alloys. Stainless steel, aluminum bronze, German silver, and brass and bronze. Such at least 10-15 you have to remember. Otherwise, you cannot answer this type of question. Stainless steel is an alloy of. Actually, stainless steel is carrying iron and nickel and chromium. These 3 are there in this particular. So, option A, iron, chromium and nickel. B, iron, nickel and manganese is C. And iron, tungsten and carbon. Iron, aluminum, nickel and cobalt is said. But in the case of stainless steel, remember, stainless steel is carrying iron, nickel and chromium. So, answer is A. Coming to question number 24. Question number 24. In the Browning test for nitrate radical, the brown color is due to ferrous nitrate, ferric nitrate, ferrous sulfate, nitroso-ferric sulfate. Nitroso-ferrous sulfate is the answer here. This is what nitroso-ferrous sulfate. FeNO SO4. FeNO SO4. This is what NO plus. This is what Fe plus. Nitroso-ferrous sulfate is the correct answer here. But brown ring complex to write, this will be Fe H2O taken 5 times NO. This is what nitroso-ferrous sulfate. Nitroso-ferric is saying no, nitroso-ferrous sulfate. This is the correct answer in this. Fe is in the plus 1 state, in nitrosyl in the plus nitrosonium. So this is the brown ring complex. This can be in short way you can call it nitroso-ferrous sulfate. So answer coming to be C. 24 answer is C. Question number 25. Question number 25. Which one of the following is an anionic complex? Check it, which is anionic complex. First one, sodium argentocyanide is given. A is sodium argentocyanide. This is what sodium argentocyanide. Option B, cupramonium sulfate is saying. NSA taken 4 times SO4. Third one, zinc ammonium sulfate. NS3 taken 4 times sulfate is saying. Option D, hexaamine platinum chloride. Hexamine platinum chloride. What is the question here? Which of the following is an anionic complex? See, this is plus, this is plus, this is minus. This is minus 2, this is plus 2. Again, this is minus 2, this is plus 2. This is minus 4, this is what? Plus 4. See, the complex part anionic, negative. This is cation, this is cation, this is cation. But here it is anion. Then what is the question? Which of the following is an anionic complex? This is the anionic complex. Therefore, answer A. Coming to question number 26. See, the charge carried by iron in potassium ferrocyanide is said. You know well potassium ferrocyanide? No? K4, Fe, Cn taken 6, potassium ferrocyanide. This is what minus 6 charge. This is what plus 4. Iron is carrying what? Plus 2 charge. This is what charge distribution. Minus 6 charges, plus 4 charges. Iron is what? Plus 2. What are the options? Check it. A is plus 3. No. B is minus 3. And C is what? Minus 2. D is what? Plus 2. Plus 2 is the correct answer. So, answer D.